Power analysis is extremely simple if you know how to do it. And we do it best, and this is what I'm here for, to explain shortly what kind of device we're having here. And then later on I'll try to focus on the most important subjects of the specifications of an amplifier, so that you can really meet the high criteria on analyzing power of an e-drive or any kind of electric system. When oscilloscope manufacturers many years ago started to use their equipment to analyze the power consumption of those e-drive systems, and that's when they created to be the standard in the market. But please trust me, do not believe what they show to you. So we're looking at the noise floor of our systems. It is completely flat from DC to 2 MHz, and it is at a level of minus 140 decibel. Having such a nice noise floor, which is over 34 decibel better than any other competitor in the market, we can now take a look again at this slide with all the harmonics of a square wave system. If you take a regular data acquisition system, the noise floor is of such a height that it is hiding most of the high frequency components. And as you can see, it doesn't make any sense to measure with, for instance, 10 megahertz of sample rate or even faster if you're hiding the tiny little components that you intended to measure within your noise floor. Forget for a moment about the rectangular shaped signals. We're applying a very nice sinusoidal shape to our amplifier. Our amplifier, like any other amplifier in the market in the world, creates some error spikes which are called harmonics. And in our case, with our amplifier, the harmonic is lower by a factor of 1 million compared to the fundamental frequency. So the total harmonic distortion, which is the sum of all those harmonics here, the sum of all of these is better than 3 ppm, so less than 3 ppm of the originally applied signal. And that is by a factor 100 better than any other device out there in the market. I told you we know how to measure and how to analyze voltage and current signals at pulse width modulated systems, so at electric drive. We know how to handle the analog data, we know how to do the math, and we do have everything surrounding so that it is just a plug-and-play experience. You can select what kind of engine you have, you click on OK, and you see the data stream of all the relevant information like active power, reactive power of the whole system, but also of all individual phases.